Yes. Great lunch, right? Is anybody feeling sleepy or something like that? Please, no, Josh, don't sleep on me. Great. Awesome. Oh, my clicky thing is feeling sleepy. Come back, come back, come back. So, such a great event, some high quality talks, right? So, how about we start by giving the organization staff our hands of applause because they are doing an excellent job. And my clicker is back. Should be back. I hope it's back. Otherwise, I'll just have to stick around here. So, yeah, this talk is about understanding rendering patterns, which is, we're going to talk a little bit about the popularity that React has. Who here uses React in the day-to-day job? Okay, or hands. Who here has used another framework like Vue, Solid, Svelte? Awesome, nice mix. So we're going to talk a little bit about these rendering patterns and how we got where we are today. And I think this is a great fit because the motto of this conference is rethink, revisit, and revolve, because we need to be aware of decisions that were made in the past and why we made those decisions in order to understand that we are using the proper solutions for whatever it is you have. And there goes my thingy again. I'm going to give up on that. But before that, who am I? So after the great introduction from Diana, I think, I shouldn't need, you probably already know it. So I work as a DevRel engineer at Crab Nebula. I'm also a Google developer expert for web technologies. And because naming things are hard, I end up changing handlers on different social media. I just made from my website this little shortcut so you can find me anywhere. And then after the talk, you can ask me anything or whatever. If you want to connect, I'll be happy to. And why am I talking about rendering patterns? Because the company I work for, Crab Nebula, we work a lot with this framework called Tori, and that's also the reason why I'm learning Rust. So Tori is a framework to build native applications with web technologies. It has this backend interface that's written in Rust, and that's what connects to the native APIs in the system. And it has then the web view part, which basically you can bring whatever framework you choose. You can use HTML with jQuery or without jQuery. You can use Angular, Vue, Svelte, whatever have you, any kind of framework. And that's supposed to work. So because of that, I end up playing a lot with different frameworks to make sure that everything works and anything like that. So because I like to switch things a lot, I got curious about sharing a little bit of what I've been learning so far. And enough of that. So let's talk about rendering things on the web. So I'm not going to go all the way back. Some people, so I'm going to go as far as React came around with a bunch of very good ideas. Like, the UI is a function of the state. That's great. That idea kind of pulls also the idea of having a declarative UI, of using rendering props, having this unidirectional data flow, and splitting our UI into different components. And that is great. And as we were looking to implement those things, or as the React team was looking to implement those things, it came out an idea that ensuring this consistency, ensuring this data consistency across your UI was kind of slow. And then raise your hands, who of you have heard this sentence? The VDOM exists because the DOM is slow. Who heard that? So I don't want to say that this is wrong, but this is an oversimplification of the facts. The DOM is not necessarily slow. What is slow is when we're doing operations of removing and adding things to the DOM. And essentially that's one of the reasons why the abstraction of the DOM, the VDOM, came to be, to address all those nice ideas, all those prerogatives. The first idea was to abstract the DOM away and make those changes in batch. So first we abstract the DOM, then we have we batch all the changes, and then finally we reconcile to the DOM, and we bring those changes back in one big punch. And that's what essentially created the perception, or that the VDOM is fast and the DOM is slow. But essentially, there's a set of operations that can make the DOM slow. Let's have a look how that works. So, some of you may be already familiar with how the reconciliation process works of the VDOM, but I just want to make sure we have the same level of understanding. This is going to be important for the next parts of the talk. So we have the root component, and the root components creates these props, A and B, that's going to propagate to their child. So what happens when prop A changes? Naturally, prop A is going to trigger a re-render on every component that's using prop A. But that's not where it stops, because as we saw very cleverly put in the first talk of the day by Ben, that some data is pulled and some data is pushed. And in this case, there is no notification of changes. There's no way each component is going to know exactly. The data is not being pushed. So the component needs to then pull all the data again, pull the state back again. So what React does and what the VDOM does essentially, and pretty much every component that uses the VDOM, every framework that uses the VDOM, is wipe everything out and bring everything back in. So since the prop was changing the root component, everything under it is going to change. And up to this point, I think everybody that works with React understands this. In my experience, things get a little bit fuzzy when we start using context, because this relationship of chaining the props, or prop drilling, more precisely, when we use context to avoid that, the relationship between the parent that has the prop and the child that's using the prop is not quite clear sometimes. So I'll ask you, what happens when we change a prop in the root component, and then there's a bunch of child in between with the provider and stuff, between the provider and the consumer in this case? What happens then? If the root is changed, everything under that provider is going to re-render. And then that's why we start having, in my experience, I saw a bunch of apps having excessive re-rendering issues. And that is, to this point, one of the aspects of the VDOM that gets developers scratching their head more often, right? Who hasn't been bugged by a component that's re-rendered way too often? You haven't been bugged by that? Oh my God, that catches me very often. Yeah. Anyways, but then we say, don't forget about memoization, right? And sorry for the pun to the ones of you that already know. But also, don't memoize everything, because premature optimization is quite bad as well, and it can get you to all sorts of troubles. But the React team is working, and this is only an RFC so far, so don't write in stone anything that I'm about to say. But essentially, my understanding so far of this RFC is that the React forget is going to be a compile time optimization that's going to auto-memoize your components for you. What does that mean? It means that, remember that tree before? We're going to split them into little blocks. So there's a block that uses the prop A. Those are going to be memoized together. There's another block that uses no prop. That's going to be memoized as well. And then there's another block that uses props B. So they're going to be memoized, and then going to be there's not going to be all those re-renderings. But that's a lot of talking. So let's do some demo, and I'm going to do the demo in the default example that we all seen, which is a counter. But because I fancy myself senior, I'll have two counters. So yeah, anyways, jokes aside, what we have here is the typical counter demo that you've probably seen over and over again. So we have the counter component that I just broke. We have the counter component over here. Yeah. And what I'm going to do is, once it's rendered, I'm going to log some information there, and then just have like a setter for the new state and the name. So then it's supposed to work. And then I'm creating 2 instances of those components. So let's re-render my page over here. And as you can see, first instance is this green color, which is a very nice, badass name. And the other one is a hot pink. And as you can see, they're rendered twice. This is a React thing when you're on the development. To those of you that don't work with React all the time, probably you're finding this a little bit strange. It's that React in dev mode, they run the rendering twice because they want to run the effects twice, because it's important for you to make sure that the effects are atomic when you go to production. So in this case, it's rendering twice. Don't get alarmed. I didn't wrote a bug here on purpose. But yeah, so what happens now? We have all the components re-rendered. I'm going to clean it up. And now I'm going to change a prop on my counter number 1. But counter number 2 didn't change anything, and it's already re-rendering as well. Same goes if I clear it out and I re-render number 2. So I'm getting a lot of re-renderings. What we need to do now, if this would be a rendering that we don't want to, we need to memoize the component, right? And that's what React Forget's going to do out of the box for us. So the way we do that is we come here and we say, yeah, I'm going to memoize my counter. And I'm going to use this memo that's coming from React. And I'm going to memoize this one. And so number 2 is going to be memoized from now on. So first render, yeah, everything happens there. And if I re-render, if I change a prop on counter number 2, counter number 1 is not memoized, so it still re-renders as before. But now, if I change a prop on number 1, only number 1 is going to re-render. And that's what, as far as I know, that's what React Forget is going to be here for. It's going to automate this thing for you. And back at it, now to the talk, back at my slides. So as you can see, even by memoizing, there are still some renderings that happen a lot more often than intuitively coming out as a fresh developer to React or to a VDOM framework you would find. It's not exactly as you would expect. And on top of that, because before memoization was optimized, the idea of memoizing was for big renderings that would take a lot of processing power and could consume a lot of resources on the machine. Because usually re-renders are cheap. So unless you have some side effect that's creating a quirk or not, you might not need to re-render. That might not be your problem. But yeah. So the thing is, we want to avoid the re-renderings, right? That's the point that we're getting at, that we don't want to re-execute the rendering function every single time something happens. And then if you're an experienced React developer, you might think, oh, the thing that actually does it for me is ref, because if memo is rerunning, even if something doesn't change sometimes, maybe I need to ref. So can I do a use ref? So if we want a value to persist across renderings, we would use that. That's what they're there for. The problem is, in this case, is that they cannot trigger a re-render in any possible way. So it doesn't really fit the bill. So that's why we cannot have useRef for that. And then with this thought in mind, some ideas came up and started to challenge the VDOM. And thinking about challenging, like some people usually like mentioning there's a framework war because there's a lot of frameworks happening and they're all fighting for your attention and stuff like that. I don't like this term. I tend to think it's more of a tide because ideally these frameworks are going to be learning from each other. We saw on the previous talk that the observer pattern is not something that's exactly new. It's been around for a while. Knockout.js used MobX on the React space used, RxJS has been around for a while. So nothing is really new, and we are learning from each other. If you look at like other frameworks that came after React, all of them, I guess, are using JSX, which is not part of React, but was kind of championed by them at some point, I would say. We all ended up learning JSX mostly because of React. So what is the plan now? So instead of, we're going to render once, and then we most often won't need to batch the changes unless it's something that the data actually needs to be batched for some reason. And then we're going to touch only what we changed. That's the idea. So demo, back to the counter. But in this case, I'm going to use a framework that uses fine-grained reactivity. And my example is written in Solid, not because Solid is the one using signals. It is one of them using signals. But it has, it is on the polar opposite in terms of it uses the signal. I don't want to say in the purest form, but I say it's the one that uses signal as the complete opposite of the VDOM, and I'm going to show you why here. So when we render a solid.js application, everything renders, right? And then again, we have the same kind of component. If you squint it enough, they look like the same thing. Like if I show you this piece of code, you could, even if you're a React developer, you can understand what this onMount's kind of doing. And if I show you here the onClick with the prop set count and then the props, you're going to find it weird that we're calling a function here instead of using a value, but you kind of can read. Or like instead of use state, we're creating a signal, but you kind of can read. But anyways, we run, first of all, it runs only once. So yeah, no twice thing for dev mode and stuff like that. Then, if I update the counter, nothing re-renders. It's not that the other one's not re-rendering. It's not that my counter's not re-rendering. Nothing is re-rendering. Same for 2. So signals are essentially different than memoization in this case, because on solid.js, what we think of is whatever runs in the function body is going to run on mount. It's going to run on the first render, and it's not going to run again because of the way that signals operate. And let's check on that then. So back. So signals are an implementation of the observer pattern. And yeah, so we're going to talk a little bit about the observer pattern. We already saw a lot of that. I'm going to piggyback a lot on the concepts that we already saw on the first talk. And hopefully, I'll be able to help the understanding a little bit more than get in the way. But let's see. So the observer pattern, in this case, we have the data that is going to notify the change. That's the push. And then the component that's tracking the change, that's going to be the pull in this. Okay, my thing is, okay. Component's going to track the changes, and that's going to be the pull. Remember, we saw that signals are push, then pull. So we have the data pushing the changes, we have the component pulling the changes, and then we get the render engine that's going to touch only that thing. So then you don't take out the HTML tag and then put back an HTML tag with a different content. You just update the content. That's the idea. But then again, we're talking observer patterns, so the natural question is, RxJS has been around. Like if you weren't there in the talk before, that would be less obvious, but why not RxJS? What's the difference in the patterns? So just try to be, I'll be very brief on that because Ben already explained that way further than I possibly could. Essentially, observables and signals, they're different. And I'll try to summarize in a nutshell, in a singular way. So the observables are going to be push-based, which means they're going to emit the data to the consumer, while signals, as I mentioned in the slide before, they are push then pull. The producer is going to notify the changes, so then the consumer can pull the changes. So it's going to say, something changed here in this state, and then they're going to say, okay, let's call the getter, and that's going to work. So all this idea and all this being based on signals approach, and I think Solid is the only one, like maybe Quick also adopted it out of the box, the other ones are bringing it in, but the fact that Solid, and that's why I'm using it as an example, I lost my thing, is that Solid starts seeing components as a little bit different than React. React said that rendering and data should be coupled inside the component. Meanwhile, Solid says, no, we have the rendering part and we have the data part, and they don't necessarily need to talk to each other. And that's the premise of signals. The data is going to update, but not the there's going to be no re-rendering. So then we get to the banter part, which needs to exist. So this friend of mine asked me, oh, which one do you use? Use state, React use state, and memo, and whatever. And I was annoying on Twitter, but just a joke. Christopher is a great friend. We both like React. But I wouldn't be truthful to you if I only came here and said, oh, signals are great, use signals, yada, yada, because everything has a trade-off. And let's talk about them, because they are different implementations, as you saw. There are good points for both of them. I've been talking a lot about how signals came into the scene, or came back into the scene. And now let's see why they weren't in the scene in the first place if they've been around for a while. So there's a few commandments when using signals. And actually, there's one big one, but this one happens so often, especially with how the React programming patterns came to be, that I need to mention it, which is you do not destructure props, because you cannot pull back the value if you don't have a function to call. So signals are going to track the changes if you're going to have a function call in this case. That's why they are able to auto-track. We're going to see some framework syntax in a few minutes, and some of them don't use that. That's because they use some compiler magic under the hood to help you out. But essentially, signals need a getter. And the second one, which is the underlying truth, is that fine-grained reactivity by itself is very delicate. So we need to do a bunch of stuff to protect it in this case. So because of that, frameworks like Solid.js have a bunch of helpers to make our life easier as developers. Do you need to use all of them? No, you don't. If you know what you're doing, you can go around it. But they're there to help you, and they're there for a reason. So before ditching them out, let's see what they're about. We have, for example, list iterations. If you remember the pattern of ul.map and then you list a bunch of items, that works well for React, because what React does essentially is if you change one item in the list, you are going to render the whole list usually. On Solid, or on a fine-grained reactivity component, you don't want to do that. So what for and index do is essentially memorize or persist or protect the reactivity, so then they store the values or the index of your array in a reference, and then when you change, either you just change the order without re-rendering anything, or you just change the content of one item without re-rendering the whole list. So that's why we have these components as helpers. We also have control flow components. So you show something when a signal becomes truthy, or you hide it, and then when you need to do a bunch of stuff, you have the switch and match combo, which works more or less like pattern matching. So you have a switch, and then you have the match cases for each thing inside the switch. Again, this can be done with ternaries in React and stuff like that, but then you have this kind of syntax sugar that helps you out protecting reactivity on a fine-grained reactivity framework. And we also have some other helpers, like for example, you have the on helper, which you use when you need to explicitly declare a dependency to something. So on this change, I want to run this code, because sometimes the rendering engine cannot really detect the tracking, or you want to add something that's unrelated. So yeah, you have create effects that are for side effects. So sometimes a signal change can trigger a side effect in your application. So you need that. Though the name, they're like use effect, but use effect end up being used to a bunch of other stuff that maybe shouldn't. Maybe that's a whole different topic. But yeah. And you have create store, because protecting reactivity on complex types like array and objects are quite difficult, because that means that when an object changes, you need to do some kind of comparison, and you want to make sure that things that are not using that key get re-rendered or not. So what store does is create a proxy object and create signals for each key of those objects or arrays, which means that you don't need to be that much worried if you're pushing elements to an array if you're using a store, because the store is going to have independent signals for all those things, and that's going to help you protect reactivity. And you have create resource in this case, because if you need to do some async fetchers and you still use signals, as you saw, because they have this push and pull strategy, then you need some assistance for that, and create resource is the glue or the bridge that gets you there. And then, at some cases, though, because of the nature of signals that touching only what changes, they're very performant. Sometimes you want to batch changes. If you already know you're going to do a bunch of changes, sometimes it's good for performance that you batch them, so you can do that as well with this. So, that being said, the main takeaway that I would love you to have from this talk is there's no free lunch. Yeah, except in revo.js, there's no free lunch. But the point is, you need to understand the tool that you want to use and make sure that that tool is gonna help you on whatever you want to build. There's no silver bullet or whatever have you. There's nothing that's going to work on every possible case. But that being said, reactivity and fine-grained reactivity have different increments. So you can have something finer or something coarse. So in the beginning, we had React doing the VDOM. Everybody was doing some degrees of that. And then Solid.js came around. And if you know, Ryan Carniato is the creator of Solid.js, and he started talking a lot about signals and pointing out the advantages and stuff like that. And he had something to say about that. And then a lot of the frameworks are implementing signals and are coming to this way. So I like that. That to me speaks back to the fact that we are all learning from each other. So let's see how it looks like on different frameworks. So Vue has the refs, and shallow refs in this case. So you define one, and you can update the value like that. So syntax is kind of straightforward, but that's essentially how you can leverage signals in Vue, though they're called differently. Quick has their quite unique syntax with the dollar signs and stuff. That's a compiler thing. Don't worry about that. But essentially, they have this hook as well, which you define a signal. And then because they're also a compiler, you don't need to use the function call. They felt it was like better DX. So you can mutate that signal in this case, but essentially you're setting. And then this is actually a signal call. So the compiler is going to convert that into a getter for you. And then for Angular, you define a signal like that. And then you can set a new value to a signal, or you can use update if you want to change the value of the signal based on the previous value. And then you call the signal with a getter as well. For Svelte, with runes, which I think they're not out yet on Svelte 5, but it's going to look something like that, apparently. So you have this $state that's going to define essentially a signal, and then you return the getter, and you can return the setter or the updater, or however you want to call it. So these are signals in all the different frameworks that we have. So, okay, so you fell asleep after lunch and you just woke up. TLDR, this is how it started. This is how it's going. So even if you're still a React developer, I do urge you to have a look about signals. I think there's something about them there that kind of translates well to the design. And yeah, thank you very much for having me and for listening what I have to say. And I'll be around today and tomorrow if you want to chat about it.